All right, cool. So, have you started it yet, or are we starting from the beginning? All right, cool. Well, let's get rocking and rolling. Okay. So this first problem is 3.2 minus 5.7 positive, negative, or 0. So, what do you think is a good first step whenever we're subtracting two rational numbers? What's the first good step? Okay, good. I like that. So in this case, we know we're subtracting, and then what comes after that? What's that phrase that we have in our brain that we always do when we're subtracting? Okay. I was thinking we change the subtraction to addition. If you take a look at that paper when we wrote down the steps for subtraction, that should be the first step. But as we do this more and more, it's going to be your first thing that comes to your brain. So we have 3.2 minus 5.7. How could I rewrite this right here as addition? Good. And why is it negative 5.7 instead of positive 5.7? Good, right? That's the phrase. And it seems like it's slowly becoming ingrained in your memory, and that's a really good sign. So now, is the question actually asking us for an answer? Well, no, it's not. It's just saying, will this result be positive or negative? Now, just by looking at this, can we determine whether it's positive, negative, or 0? Good. That is a perfect explanation. I couldn't have said it better myself, right? Because when we're adding two numbers with different signs, the way we get our sign is by looking at the bigger number, right? Our bigger number in this case is negative 5.7, so we use the negative sign, so our answer is negative. Good. Do you have any questions about that process? Okay. Let's move on to 1b. We have 3.2 minus negative 5.7. And we decided that changing this to addition was a good first step, so how can I rewrite this as addition? Good, that's exactly right. And why is it 5.7 instead of negative 5.7? Right, and the opposite of a negative number is positive, so this becomes positive 5.7. Good. Now, just by looking at this equation, can we tell whether the answer is going to be positive or negative? Good. And when we add two positive numbers, we get a positive number. Good. So any questions about that? Awesome. So number 2 is the same idea, but we are working with fractions, so there are some few steps that we have to take. They're a little bit different. So we have 2/5 minus negative 5/6. So what's a good first step to decide whether this is positive, negative, or 0? Good. Right, same idea. And how can I rewrite this subtraction problem as addition? Good. And it's positive 5/6 because our number inside our parentheses is negative and the opposite is positive. Now, how do we add two fractions that have different denominators? Good. So how do we change those denominators? Good. And now that I think about it, actually, do we actually need to solve for the answer to determine if the answer is positive, negative, or 0? Or can we determine the sign of the answer just by looking at this right here? Good. And why were you able to determine the sign? Good. So our answer is going to be positive, and we're good to go. Okay, let's move on to 2b. So we have 2/5 minus 5/6. What's our first step? Good. And how can we rewrite this as addition? Good. And when you said minus, I think you meant to say plus, but exactly right. So is this process getting easier, the rewriting to addition, for you? Good. And it seems that way. You made a lot of progress. I remember last week, you probably got like 50% of them right, but you're on top of it with every single one. So that's a really good sign. So can we determine the sign just by looking at this addition right here? Okay, and why do you think that we can? Good, so the numerator is bigger on this side, but the denominators are different. And that's kind of the key to this problem. If these denominators were the same, we'd be able to say, okay, 5 is bigger than 2. We use the negative and our answer is negative. But we don't actually know. It's actually hard for us to compare these fractions if the denominators are different, right? So if the denominators are different, we have to find a common denominator. Does that make sense why we can't compare these two fractions? Okay, good. Common denominator, I've got this down pat. My multiples of 5 are good. And multiples of 6, 6, 12, 18, 24, 30. And 30 looks like a common denominator. So, how can I rewrite 2/5 so that it has a denominator of 30? Good. Do I have to multiply my numerator by anything? Good. 2 times 6. Good. And we decided that 5 times 6 was 30. Now let's rewrite this fraction. How can we change this fraction to a denominator of 30? Good. Numerator by 5 as well. 5 times 5. Good. And 6 times 5 is 30. Okay, now that our denominators are the same, let's rewrite this problem. We have 2/5. That is not rewritten. We have 12/30 plus -25/30. Now we can compare these fractions. And how do we compare those? How do we decide what sign our answer is going to be? Good. And the reason we're able to compare these numerators is because the denominator is the same. Okay, do you have any questions about that process? Maybe when can we compare fractions? Something along those lines, or are we all good to go? Good. Alright, so that was 2b. Move on to number 3. Okay, so we have -1/3 minus -5/12. And hey, this is the step we were just practicing. They're saying, how can we rewrite this subtraction as addition? So, how can I rewrite this subtraction problem as addition right here? Good. -3, or -1/3 rather, plus, and is this number in the parentheses positive or negative? Good. Okay. And what letter looks like that addition right there? Good. Great. Number 4. So we have this subtraction problem, -14.7 minus 7.1. And they're saying, what is the first step when finding the value of this expression? So, what's the first step that we've been preaching this whole time? Good. So, for A, we have A. And what is the opposite of 7.1? Or -7.1 rather? Good. So we have -14.7 plus 7.1. And now we can just go ahead and solve. How do we add two numbers with different signs? Without using our calculator, maybe? Okay, so do you remember how we had that list of steps to solve addition problems with different signs? So I appreciate that you're going and trying to figure it out in your head. And that's good if you're kind of just, messing around or like just want to try to guess. But if we stick to the script, our answer's always going to be right as long as we don't make any mistakes. So what was the script, or what was that first step that we had when we were adding two numbers with different signs? Do you remember? Good. Good, good. And I know it can be tempting to skip over those steps because, I don't know, I feel like we've done so many of these problems. But in math, sticking to the script works. So good. I'm glad you remember that. We find the absolute values. Now, what do we do with these absolute values right here? Good. Okay, good. So now we know the sign of our answer. Now, how do we actually calculate a number for our answer? Okay, no worries. I can refresh your memory. We subtract the bigger from the smaller. And don't even worry about, forgetting that. It's kind of easy to get all of the steps mixed together. But we did write down these steps somewhere, so whenever you're doing these types of problems, maybe keep those notes handy, so if you ever forget, we don't have to guess. We can, we could stick to the script that we have, and it's totally okay to peek at that sometimes, right? Okay, nice. 14, okay, 7.6, and we decided that it was negative, so our answer is negative 7.6. Any questions? Good. Alright, you ready to move on to the next problem? Cool. So we are moving on to the next section in the book, right? We're talking about distance. So I'm assuming you guys went over that in class either yesterday or today. Okay, and how did you feel about it? Did it make sense? Was it confusing? Okay, then let's try to work through this problem then. So we have the temperature in a town is 36.6 degrees during the day and negative 12.6 degrees at night. And they want us to solve for the difference between the temperatures. So, we have this nice little formula. Absolute value of A minus B is equal to the distance. Is that formula familiar to you? You said no, it doesn't? Okay, no worries. So we started to go over it last week. But basically when we have 2 points or two numbers and we want to find the distance, the way we do it is we take one of the numbers. It can be either one. It doesn't matter the order. So 36.6. Is it ringing a bell now? Cool. All right, that's a good moment to have, right? That aha. Minus 12.6, and the absolute value of this will be equal to our distance between the temperatures. And do you remember anything last week we talked about how it doesn't matter which number we plug in for A and for B? Okay, good. So this should be our answer. Now, how can we go from here? We have this equation. How can we solve this subtraction problem? Good, right? And we add the opposite. So I have the absolute value, 36.6 plus, what number goes in my parentheses? Good. Now, I know how to add two numbers with the same sign. That's the easiest type of problem that we have, right? 36.6 plus 12.6, 6 plus 6, 12, 6, 8, 9. There we go. The difference is equal to 49.2. Do I need a unit for this answer? Or can I keep it as just a number? Good. So the difference is 49.2 degrees Fahrenheit. Okay, do you have any questions about this formula right here? Which number to plug into A or B? Or what does this even mean? Or anything like that? Yes. So we can also, so this is how we chose to write it. We can also write this as negative 12.6 minus 36.6. It would be totally acceptable. The only thing we have to remember is we have to keep the signs. The signs of the numbers have to stay, or else our answer won't be right. So if I decided, oh, I want to write this as 12.6, or I want to write this as 36.6 minus 12.6, because, oh, look, the minus sign is right there, it's okay. No, cannot do that. We have to make sure that if we have a negative number, we are subtracting the negative. If we have a positive number, we keep it positive. Does that make sense? Good. So let's do one quick example. We have one more minute. Let's say I wanted to find the difference between 10 and negative 40. What are the two ways I could write this equation? Good. Good. Right? And so that's good, right? We have to keep the negative here. So it's 10 minus negative 40, or negative 40 minus 10. And then the absolute value makes it so that these are going to be exactly the same. Okay. Do you have any final questions before we